The world is shrinking. There's a deep and relatively unexplored world beyond what the human eye can see. The microscopic world is truly alien and truly fascinating. I'm delving further than the microscopic scale. I'm going to explore the potentials of working at a nanoscopic level, working at a level a billion times smaller than the average scale we work at today. This is nanotechnology. Nanotechnology means any technology on a nanoscale that has applications in the real world. Nanotechnology is the science of building small, and I mean really, really small. It's pretty difficult to imagine.
So, what is nanotechnology? It is the study of controlling or manipulating of matter on an atomic and molecular scale. Generally, nanotechnology deals with structures sized between 1 to 100 nanometer and at least one dimension, and involves developing or modifying materials or devices within that size. So, this is the history of nanotechnology. It is the first ever concept was presented in 1959 by the famous professor of physics Dr. Richard P. Feynman. Invention of the scanning tunneling microscope in 1981 and discovery of fullerene in 1985 led to the emergence of nanotechnology. The term nanotechnology has been termed by Norio Taniguchi in 1974.
So now let's proceed to the nano and technology. A nanometer is a unit of length in a metric system equal to 1 billion of a meter. Technology is the making, usage, and knowledge of tools, machines, and techniques in order to solve a problem or perform a specific function. So there are the innovation application. First is energy, medicine and drug, nanobiotechnology, nano devices, optical engineering, defense and security, bioengineering, cosmetics, and the last is nanofabrics.
The number two approaches in nanotechnology is the top-down. In top-down approach, nano-objects and materials are created by larger entities without bouncing its atomic reactions. Usually, top-down approach is practiced less as compared to the bottom-up approach. Solid-state technique can also be used to create devices known as nano-electromechanical system, in short, MEMS, which are related to microelectromechanical system, in short, NEMS. Microelectromechanical system became practical once they could be fabricated using modified semiconductor device fabrication technologies, normally used to
Carbon nanotubes. Nanotubes are allotubes of carbon with critical nanostructures. They have a length of diameter up to 132 million. Nanotubes are member of fullerene structure family. Their name derived from long, hollow structure with a wall formed one atom thick sheet of carbon called graphene. Properties: high strength of penetration help to creating weight of spacecraft. Easily penetrate members such as cells wall help the cancer treatment. Electrical resistance changes significantly when other molecules attach themselves to carbon atom. Help to develop sensors that can detect the chemical vapor.
Applications. So there are 8 facts about application. So the first one is replacing transistors from the silicon chips as they are small and emits less heat. Next one is in electric cables in wires. Third is in solar cells. The fourth one is in fabrics. Fifth is research is expected to lead to new materials, lubricant, and medical application. Sixth is devices or energy storage and energy conversions. Seventh is sensors. And the last one is reduces the damages caused by treatments such as chemo. Advantages of CNT. So there are 4 advantages of CNT. So the first one is produces smaller and faster components. Next is this will also result in computers that consume less energy. The third one is high speed and high capacity memory. And the last one is allow circuit to be more accurate on the atomic level.
My topic is the God particles. The Higgs boson was found in March 2013. It's a particle that gives mass to other particles. So Peter Higgs was the first person who have think of it, and you could find it everywhere. The Higgs particles is a boson, and boson are particles responsible for all the physical forces except the gravity. These particles are believed to exist for less than a septillionth of a second because the Higgs has so much mass compared to other particles. It takes a lot of energy to create one. And the Large Hadron Collider is the equipment scientists use. And the second one is petfuls. Nanoparticles can get into the body through the radicals that can cause cell damage. So once nanoparticles are in the bloodstream, they will be able to cross the blood-brain barrier. So the most dangerous nano application used for military purposes is the nano bomb that contain engineered self-multiplying deadly viruses that can continue to wipe out a community, country, and even a civilization. So nanobots, because of their replicating behavior, can be a big threat to gray god.
Scope in future. Nanotechnology may make it possible to manufacture lighter, stronger, and programmable materials that require less energy to produce than conventional materials and that promise great efficiency, such as land transportation, aircraft, ships, and space vehicles. In the future, nanotechnology could also enable objects to harvest energy from their environment. New nanotechnology or new nanomaterials and concepts are currently being developed that show potential for producing energy from movement, light variation in temperature, glucose, and other sources with high convention efficiency. The future of nanotechnology could be very well include the use of nanorobotics. These nanorobotics have the potential to take on human tasks as well as tasks that human could never complete. The rebuilding of the depleted ozone layer could potential to be performed. This would be an entire nanosurgical field to help cure everything from natural aging to diabetes to bone spurs. Thank you.
Nanotechnology in fabrics. The properties of familiar materials are being changed by manufacturers who are adding nano-sized components to conventional materials to improve performance. For example, some clothing manufacturers are making water and stain repellent clothing using nano-sized whiskers in the fabric that cause water to build up on the surface. In manufacturing bulletproof jackets, making spill and dirt resistant antimicrobial, antibacterial fabrics. Nanotechnology in electronics. Electrodes made from nanowires enable flat panel displays to be flexible as well as thinner than current flat panel displays. Nanolithography is used for fabrication of chips. The transistors are made of nanowires that are assembled on glass or thin films of flexible plastic, e-paper displays on sunglasses, and map on car windshields.
Nanotechnology in computers. The silicon transistors in your computers may be replaced by transistors based on carbon nanotubes. A carbon nanotube is a molecule in form of a hollow cylinder with a diameter of around a nanometer, which consists of pure carbon. Nanorods is an upcoming technology in display techniques due to less consumption of electricity and less heat emission. Size of microprocessors are reduced to greater extent. Resources at North Carolina State University says that growing arrays of magnetic nanoparticles called nanodots. As a conclusion to this topic, I would like to say that nanotechnology is a brand new technology that has just begun. It is a revolutionary science that will change all what we knew before. The future that we were watching just in science fiction movies will in the near future be real. This new technology will first of all keep us healthy because of nanorobots that will repair of all keep us every damage that we have in our body. Secondly, it will give scientists the ability to manipulate the combination of atoms in an object and to turn it into a combination and a lighter, stronger, and more durable object than before, just by using carbon nanotubes that are known to be 100 times stronger than steel, and in addition to that, they are very flexible. Thirdly, nanotechnology will give us abundant energy because it will transform energy more effectively.